Hello, I'm Puneet Talwar, graduate student in CSU, and I'll demonstrate my challenge assignment of flash memory programming with Watchdog technique. The problem statement is to write flash 128KB flash main memory location in every 1 minute, and in doing so, the Watchdog timer should be configured to reset the system in 1 second, and this must be prevented by the software. So let's come into the main function. First of all, we hold the Watchdog timer. Then we'll initialize the ports. See the definition of initialize function. We have initialized port 1.0 and port 2.1 as outputs. So at port 1.0 a red LED is there, and at port 2.1 a green LED is there. These are configured as output, and at port 1.4 there is a switch which is configured as an input. So every time the switch is pressed, an interrupt service routine is called. After initializing the ports, we'll set the Watchdog timer to reset the system in 1 second. The input to Watchdog timer controller is B clock, which is set at 32 MHz. And by using this configuration, Watchdog timer resets the system in 1 second. Now we have to prevent this reset. So for that, I'm using Systick module. The Systick has been configured to generate an interrupt once in every second. And when the Systick handler is called, I refresh the Watchdog timer counter so that the program is not reset. So here's the definition of Systick handler. I refresh the counter so that the system is not reset. After setting the Watchdog timer configuration, we move on to the erase in program flash. It is in while loop since this program has to be repeated again and again. So now we'll look at the definition of erase in program flash. Our objective is to erase and program 32 KB of main memory in flash. So now let's look at the definition. We have initialized a buffer of 4K memory, and we have initialized to a pattern of A5. We can initialize any pattern. So now we will unprotect the sectors. In every bank, flash bank, main memory bank, there are 32 sectors. So we need to unprotect the 32 sectors, which we are achieving by this piece of code. After unprotecting the sectors, we'll erase the memory in those sectors. Again, there are 32 sectors, so the loop will run for 32 times. After erasing the sectors, we'll copy the contents of buffer into those 4K locations, which will repeat it 32 times. So this piece of code will ensure that the 128 KB flash memory in 128 KB flash memory A5 pattern is written. So after writing in 128 KB flash memory, we need to unprotect the sector. So we'll unprotect the 32 sectors. So after unprotecting the sectors, this operation takes certain amount of time. So in order to note what amount of time it takes, this operation takes, we use a count variable. Every time the erase in program function is called, we initialize the count to 0, and count is incremented in the Systick handler. So till the time the control shifts here, the count has been incremented, and the count gets incremented continuously in the Systick handler. So the value of count in this statement is the time it takes for the whole erase and write operation to take place. So we calculate the count to 60 seconds, which is 60 minus the count it took to erase and program the memory, and then we call a delay function. And the delay will let's look at the definition of the delay function. This delay function will calculate, this will give a delay of a seconds, where a is the 60 minus the count. So now we'll get back to the definition. So after the delay is called, we green LED should come on for 1 second. So a green LED is turned on. After a delay of 1 second, the green LED is turned off. So this is one part of our challenge assignment. Now the second part is when we long press the input switch, the program must reset. And if there is a short press, the program must not reset. Now we'll look at what happens when the button is pressed. Whenever the input button is pressed, an interrupt service routine is called. This function is called, and in this function, if there is a long press, the control shifts to this while loop, and the watchdog timer counter, it counts up. So whenever there is a long press, the watchdog timer resets the function, and if there is a short press, the control doesn't shift in this while loop. So the functioning is normal. But whenever there is a long press, the watchdog timer resets the function and the control shifts to this one, the start of the program. And after this, the red LED must go on. The red LED turns on. There's a delay of 1 second, and then the red LED turns off. So this is the complete challenge assignment. Now we'll debug and run the program. The program is debugging. After that, in order to observe the behavior of the program, we can put breakpoints. I'm putting breakpoints here. This will indicate that the erase has taken place, and at this point it will indicate that write has taken place. So now let's run the program. Then the program control shifts here. Then at this point, the contents of memory location of bank 1 must be FFF. We need to open the memory window. Now we'll look at the value of stored in these memory locations. This is the start of the sector. So when we see the value stored at this location, there is a F. These are all F. This is indicating that the erase function is operated correctly. So now we'll move to the next breakpoint. It will take some time to write into these locations. After the control shifts to this point, we can observe that in all these locations, a pattern of A5 must be there. So we can see write operation has taken place. So there's an A5 pattern in all the memory locations. We can also observe the whole time, the amount of time it takes for the whole erase and write operation to take place by placing a breakpoint at this point. At this point, the green LED will turn on. So I'm putting the code. So the time we can also observe the time in energy trace profile. So after 60 seconds, the control will shift at this point, indicating the green LED will turn on. So we'll wait for 1 minute. So we can see in exactly 61 seconds, the control shifts at this point, indicating that the whole operation takes a minute. We can also see if the green LED is turned on for 1 second, by placing a breakpoint at the point where LED is turned off. So this takes around 1 second. Now we'll see what happens when I press the input at 1.4 port. So when I press the button, this function will be called and the program control will be transferred at this point and will stop at this point since a breakpoint has been placed here. So right now I'll be doing a short press. So let's observe. When I press the button, the program control shifts at this point. I'm sorry. So this indicates that port ISR handler is called whenever the switch is pressed. Now we will observe what happens when I long press the switch, input switch, that is at port 1.4. Play the code. The program is not reset. The program control never shifts here. If I press a breakpoint here, the control never shifts here. But if I long press the button, since the watchdog timer will reset the system, the program control will be transferred at this point. So I'm pressing the long press. I'm long pressing the switch at port 1.4 now. So we can see the program control has been shifted at the very beginning of the program, indicating a reset has taken place. So this successfully demonstrates the challenge assignment. Thank you. We will see the demonstration of a project on the hardware. Now I have burned the code into the hardware. So after that, after I click the play button, the red LED will glow for 1 second. That indicates the system has been reset. And after that, the read and write, the erase and write of flash main memory will take place, and that will finish after exactly 1 minute. So that event will be marked by a green LED which will glow for 1 second. So I'm clicking the play button and simultaneously I will click on the stopwatch to show that it takes exactly 1 minute for the green LED to glow. So So as we can see, the timer has been set on. After around 37 seconds, the erase and write operation completes. After that, the delay function comes into action. So I'll bring my focus to the board. So as we can see, it took around 59 seconds for the whole operation to complete. That's around 1 minute. Now we'll demonstrate the long press functionality. So for every long press functionality, for small press functions, for small press, the system must not reset and the red LED must not glow. But for long press, the red LED must glow for 1 second. So I'll press the switch at port 1.4 and this will be a short press. So the red LED doesn't glow. If I long press for more than 1 second, then the red LED will glow. So that's it. After I long press 1.4, the Watchdog timer, it resets the system, and once again after resetting the system, the red LED glows for 1 second. So that's about the whole demonstration of the challenge assignment. Thank you.